How would you feel about working in the field of physics? You could be a research or applied physicist in acoustics, astrophysics, astronomy, atomic and molecular physics, electricity and magnetism, energy conservation, geophysics or health physics, medical imaging, nuclear medicine, solar energy, solid-state physics, scientific computing, or you could be a science educator. Get the idea? The possibilities are endless. Today, we are going to focus on just one discipline in the field of physics, specifically acoustical engineering. Sacramento State has a unique facility for studying acoustics, and it's really cool too. William DeGraffenreid is a professor in the Department of Physics and Astronomy. His area of expertise is atomic physics and scientific instrumentation. Today, he's working with students in the department's acoustics course.
Acoustics is the science of sound. When we study acoustics, we study how sound waves propagate, how they reflect, how they interfere with each other, how they get absorbed. Acoustics is used in the study of sound, hearing, music, building design. Acoustics is used in designing your new concert halls to make sure that everybody hears exactly the same thing. In acoustics, we also study noise, the sources of it, and how to get rid of it. Fortunately, here at Sac State, we have a nice quiet place where we can do some work. In the anechoic chamber, we're completely isolated from outside noise. In addition to that, the walls are designed to absorb any echo. Echoes can make it difficult for us to measure certain effects. The echoes will overwhelm what we're trying to measure. The way this chamber is used is it's designed to absorb the sound waves that are produced inside here. What happens is the sound waves come in, they hit these angled surfaces, and they get absorbed as the reflections continue inward. Today we're going to be measuring the interference pattern produced by these two speakers. Just like when you drop two pebbles into a pond of water, you get waves that interfere with each other, you get crests and troughs, high points and low points. Same thing happens with sound waves. Anti-reflective walls, we can really measure that very carefully. We've got a microphone mounted here, and Matthew's out in the analysis room recording the sound at that point. And we're going to move it around the room and see what the interference pattern looks like. See, it's going to take longer to update, but see, you've got a lot more lines. It's got a lot more data.
The microphone inside the chamber is measuring the sound, and on the screen it is plotting a Fourier transform of the frequencies that we're measuring.
People with backgrounds in acoustics can find a career in very broad areas. Things like in medical fields, such as designing new ultrasound techniques. People can get jobs looking for the next deposits of oil and oil-bearing rocks. They can find fish too and design new techniques to help find fish in the ocean.
Thanks, Professor DeGraffenreid. So, that's pretty cool, huh? And remember, acoustical engineering is only one of the many choices you have here at Sac State. If you want to hear more about acoustical engineering or any physics subject, here's where you can find more information. Log on to www.csus.edu and click on Information for Future Students. Or visit the STEM website at www.csus.edu/STEM or call 916-278-2789.